Alright, this is problem 32 of Neetcode on 50, search in a rotated sorted array. So we're going to be given an array of integer, and we're going to be given a target, and the target is a value that is potentially in the array. It can also not be in the array. If it is in the array, we are going to have to return the index of that value in the array. Otherwise, we're going to have to return a -1. So um, let's let's first assess what rotating means here in this problem. So rotating basically just means taking the first number and placing it at the end. For example, this array here has never been rotated, while this one has been rotated twice. So you can see that the one has first been placed at the end, and then the two, which was then the first value of the array, has been placed at the end. Here you can see that the value has been rotated quite a lot of times, so 4 times, and here it has been rotated 5 times. So the first thing we want to check is basically once we have our search algorithm, the first thing is going to be to assess what is our search algorithm. So let's not assess that this is something that we already decide. Let's just go ahead and read the problems and try to figure out what is the best way to solve this. So it basically tells us that we should not run a problem in a time complexity of big O of n. Right, so that will be basically sorting or taking the index of the array in a brute force method. But now they ask us to find it in a time complexity of big O log n. And do you know a search algorithm that uses a time complexity of big O log of n? Well, binary search does. So in our binary search, we always set a right pointer and a left pointer, or I like to call them the start and the end pointer. So let's go ahead and write just this, okay, for each of them. So we have our start and our end pointer. All right, and we also have the middle value, which is usually the integer division between the start and the end indexes. So it has to be rounded towards 0. So if you have an array of length of 6, you're gonna have the value of the index at the end, which is 5, plus the index 0. So it's going to be 5 divided by 2, which is 2.5. But since we want to round it toward 0, it's going to be 2. Okay, so we have also this phenomenon for every single array. So we first set up our middles, right? And now the thing that we want to check is basically if the value of the middle is greater or smaller than the value of the start. And what is this going to change? Okay, let's say the middle value is smaller than the value at the start, right? So these two arrays. Okay, in this case, we know that if the value of our target is smaller than the value of the middle, and it is also greater or equal than the value of the left pointer, it has to lie on the left side. Otherwise, it is on the right side, right? Because basically, since the middle value is smaller than the left value, we know that the value of the middle up to the value at the right pointer is going to be basically an ascending order. It's never going to decrease. This might not be the case for the other scenario, but we're going to take a look at it later. So what do we do basically if our first statement is true, that the middle of the value is smaller than the middle of the target, and that the target is let's say smaller or equal than the value at the end. So let's just first start our conditions. The first one is that the target is 4. So we are going to take a look at our arrays where the value of the middle is smaller than the value of the start. Okay. And if the value at the middle is smaller than the value of the target, and that the target is smaller or equal than the value at the end, right? The smaller or equal is important. We cannot only say smaller. Well, then we have to place our left pointers by one to the right of the middle. And by doing this, we're going to cross the left section. And same thing here. If is the target greater than the value of the middle, and is the target smaller or equal than the value of the end? Yes. So we're going to set our left pointer by one to the right of the middle, and basically crossing this. All right. So by doing this, we're going to find a new middle. Okay. And we are going to use the same logic. First, is the value of the target equal to the value of the middle? If yes, we can just return the index. All right, so we're going to return 5. Otherwise, we have our check. So is basically the target greater than the value of the middle? And is the target greater or equal than the value of the end? Yes. So we're going to set our left pointer by 1 to the right of the middle. And you can set now. We basically figure out an array of length 1. So we know that that the array, or that the target is at the index 5. And I just noticed that I made an error on the bottom array. All right, so the index is 4. Great. So now we set this case, but let's see what do we do if basically the value of the middle is greater than the value of the start. So first we want to check if the target is smaller than the value of the middle. Okay. So if the target is smaller than the value of the middle, and the target is greater or equal than the value of the start, this is our signal that the target is going to be on the left side. Okay. So if our target is smaller than the value of the middle, and is our target greater or equal than the value of the start? In our case, no, right? So for the first array, no. So we're gonna put our left pointer by 1 to the right of the middle, and our new middle is gonna be 5. Now let's see the array just below. We're gonna see if the target is smaller or equal than the value of the middle. First statement is true. And also, is the target greater or equal than the value of the start? Yes. So we're gonna set our right pointer by 1 to the left of the middle, and we're gonna cross the rest of the array. All right, and our middle is gonna be 3. Now we're gonna do the same check again. So is the value of the middle greater than the value of the target? Yes. And is the target greater or equal than the value of the start? Yes. So our left pointer, or our right pointer, sorry, is gonna go by 1 unit to the left of the middle. And by doing so, we figure out what the index is. It's going to be 3 here. And lastly, is the value of the middle greater than the value of the target? It fails already. So we are going to move our start pointer by 1 to the right of the middle, just like this. And by doing so, we figure out that the index of the target is 1. So let's go ahead and start coding this. So first thing we want to do is basically our start and end indexes, where the start is going to be equal to 0, and the end is going to be equal to the last index of the array nums. All right, and now we're going to start our while loop, and we're going to while. We're going to go through the loop basically until the start is equal or greater than the end. And we are going to set our middle, or let's just call it mid, to the start plus the end with the integer division by few. And now we want to check basically if the target is equal to the number at that mid value. And in this case, we want to return the mid because we found the target's index. Okay, and now we have our first if statement. So first, we want to check if the value of the nums array at the middle. So is what if it is, what do we do if this is smaller than the value of the start? So if this is true, it must mean that all the numbers to the right of the middle are going to increase. All right. So if the target is greater than that middle value, and it is also smaller or equal that the end value, we are going to have to set our start pointer by 1 to the right of the middle. Okay. So if in the array nums at the index of the middle, that value is actually smaller than the target, and that the target itself is smaller or equal, because we might actually, our target might be at the end of the array. So just like this. This is where we want to set our start to the middle plus 1. Okay. Otherwise, we know for sure that our value is on the left side. So we are going to set our n to the middle minus 1. All right. So this is the entire logic for the first case. Now, what if the value at the middle is actually greater than the value at the start? This is where we want to check the value of the middle. So if this is greater than the target, all right, and the target is greater or equal to the value of the starting index, this is where our n is going to equal to our middle minus 1, because we now want to reach the left half of the array. And otherwise, well, we know that we are going to have our target in the right side if the target appears to be in the array. All right, and if it doesn't work, so if we never return a true statement, it must mean that the value is not in the array, and in this case, they want us to return minus 1. So if everything is right in my code, it should works. So we get a wrong answer. I wrote middle a couple of times, but actually I used the value mid. So let's go ahead and rerun this. And there we go. So this is how you solve the problem 32 of Neetcode 150. I hope you learned from this video, and I hope to see you in the next one.